I love photography. I mean, if I had the time, I'd probably run away somewhere and take some good pictures. This is a place that was just about 2 hours away from Woodstock School, where I was teaching at one point in time, a little village called Takarna. In fact, this picture just seems like a picture from, a scene from a Bollywood movie. There's this lady who's holding on to a little calf of a goat, and there's someone else in the background. So beautiful, just looks like a Bollywood film to me. And then there's this another picture of a man who's just grazing cows on the little field, little patch of land in the mountainside. And what's this? This is I love the colors. How the colors pop out. Chilies, basically. You might have just noticed that when I was just turning off that layer, you could see the picture through. And the reason I wanted to show this was not just to show off my photography, but the idea of composite pictures is the same as the idea of composite functions. Very same. Okay, just hear me out. You've got these two pictures. There's the picture of this lady, okay? But the moment I turn on, under that picture is another layer. On another layer is another photograph of a man who's grazing cows. But when I turn on both the layers here, it's a new kind of a composite. Of course, it's not great. People who are into compositions, photography or into After Effects, that's composite for films, they know the art, how you should, feather out, and how you should, there are different blend modes. If you just go here, or there are different blend modes. You go on screen, there's a different kind of thing. Color dodge, you'll get something else. So you got to work smartly as to what kind of image will pop out. That's like saying layer 2 of layer 1. You know where we're going with this, right? Layer 2 of layer 1. So when I turn off a layer 1, that's just the first layer or one function by itself, all right? This one is just the second function by itself. The moment I have both the functions turned on, I've got a totally new result, a composite of these pictures. And guess what? You change the order of the photographs, you'll get a different output. Now, composite functions might seem a little bit more boring. At least the algebra of composite functions, let's be honest, okay? The algebra might seem a little bit more tedious, but just as we saw in part 1, keep using the words input and output. Don't just read it as f of x. Say f of an input is equal to input plus 2, or whatever the definition of that function is. In the same way, when you're dealing with composite functions, use the same words. Output of the first function is the input of the second function. And that will make your algebra a lot more easier to understand, and you'll enjoy it because you'll put it into context. So let's continue. Fourth question, f of x. That's kind of weird, f of x. Normally we say two different functions that you're trying to compose. This is f of x. Well, we'll talk about that in some other video, what it means to compose the same function over and over again, right? So, but let's do the algebra part of it. This video is focusing on the algebra of composite functions. So let me write down f of x as f of x plus 2. All right, because x plus 2 is what f of x is defined as, which means we're saying this is the inside function. And so the inside function, the output of the inside function now becomes the new input for the outside function. In this case, both are the same, but it's just a very interesting way to understand input and output, okay? So remember that f of the input, the way f was defined was input plus 2. So input plus 2, but now the input itself is x plus 2. So I'm going to write x plus 2 here. Okay, there's a new input. So the final value of this f of x would be x plus 4. All right. Okay, next question. Find x where g of f of x is 5. Now that is a very different question compared to anything that we've seen so far. Find x means you're looking for the input. They've asked for the input where the value of the output is 5. All right. So the output of the composite, the output of the second function is what we're looking at. Now, you know what? There are two ways to do this question. One is just to equate g of f of x, which we found here. Can you see that? In the second question, we found g of f of x, and we found that to be equal to 3x squared plus 16x, 3x squared plus 16x plus 21, all right? You can equate this to 5 and then solve the quadratic, all right? So that's one way to do it because you've already solved g of f of x. And the question said find x where g of f of x is equal to 5. So you just have to equate this equal to 5 and you can solve for x. But what if this was not given? Meaning, the question did not have this part which, requires us to find g o f of x. They have just given us f and g as defined here. And the question just said, find x where the composite g o f of x is equal to 5. That's literally like saying find the input for this composite where it's equal to, where the output of the composite g of f of x is equal to 5. Keep using those words input, output. I think that will make it easier to understand all this algebra. Otherwise, algebra can get a little confusing. What we have is g of f of x is equal to 5. That's what we want to solve. What this means is g of some input is equal to 5. Some input, whatever that input is, okay, we're calling, remember I said, use those words, g of the input is equal to 5. But g is defined for any input. G is defined as 3x square plus 4x plus 1. Again, if we were to use the word input, it means 3 times the input square plus 4 times the input plus 1. That's equal to 5. Let's solve this quadratic, okay? This would be 3x square plus 4x minus 4 is equal to 0. And a quick factoring of that would be 3x minus 2 x plus 2, right? Let me just check this quickly. Minus 2 plus 6. Yeah, that's right. So that the value of x you're going to get is 2 over 3 and x is negative 2. But if you use the words input, that the input is 2 over 3 and the input is negative 2 when the output of g is 5, then when you read this, that the input was actually equal to f of x, that would mean that f of x, is this visible on the camera? F of x is equal to 2 over 3, okay? And f of x is equal to negative 2. That's what we've got here. We said g of x is equal to 5 because g of the input, but the input was f of x. So we equate f of x as 2/3 and f of x is equal to negative 2. And then when we solve, you know that f of x is defined as x plus 2. When we solve x plus 2 over 2 by 3 and x plus 2 is equal to negative 2, you can find the value of x, all right? So let's do that quickly. You'll get x is equal to negative 2 plus 2 by 3, which should give you negative 4 over 3. And here you'll get a negative 4. So x is equal to negative 4 by 3 and x is equal to negative 4 should be interpreted as the input of this composite function whose output happens to be 5. If I were to summarize all the algebra of composite functions that we saw in this video, I would say, first of all, that use the words input and output, okay? Don't just say f of g of x. When you write f of g of x, make it a habit to say in your mind that this is the output of g that has now become the input of f, the output of the inside function. This is the inside function or the first function, the output of the first function. That's the first function. The output of the first function has become the input of the second function. That's the second function. Okay, so use those words, and I think that will help you in the algebra of composite functions. The second thing that we saw was the notation f o g of x. This is a strange notation, but this means the same thing, f of g of x. And the third thing that we saw was f of g of x is not the same as g of f of x. And perhaps in some other video, we will see the significance of that statement. A composite function is also described as a function within a function. Now that should really make us think whether any two randomly chosen functions can be combined to form a function within a function. What do you think? Let me know in the comments below.